Hey everyone. All right, so last time I made a little screencast using Jamovi to show you how to plot the differences in baby A and baby B ratings depending as a function of group, whether you thought that baby A was preterm and baby B was full term or vice versa. This week in tutorials, we're going to write results sections. So we need some statistics to describe. So what I'm going to do now is show you how to use Jamovi to run independent samples t-tests to see whether there were any statistically significant differences in the ratings that group 1 and 2 gave baby A and group 1 and 2 gave baby B. Now, the reason that we're using independent samples t-tests and not using paired t-tests, that is comparing the within group 1 your A and B ratings and within group 2 your A and B ratings, is that actually you will have noticed the level of locomotor skill that baby A and baby B exhibited were actually not perfectly matched. So in this situation, it makes more sense for us to compare what group 1 and group 2 thought of baby A and what group 1 and group 2 thought of baby B in an independent samples way. We're comparing the ratings of group 1, who were a different group of participants than group 2, right? So I'm going to open up Jamovi here. I had to download it on my home computer, so it might look a tiny bit different. All right, so I'm going to read in the data again. I'm going to import, put the data file on my desktop. And I'm going to see if I can get rid of this screen and maybe make this one bigger so that you can see better. Okay, okay, I'm not sure why it has added 3 extra columns here. I don't know why there's extra columns. But we seem to have the data that we were using before. So we have information about participant ID, which group you were in, and then mean ratings for baby A's fine motor behavior, baby B's fine motor behavior, A, gross motor behavior, B, gross motor behavior, play behavior, and self-help behavior. All right. So what we want to do before we, just to make things a little simpler, rather than comparing individual locomotor skills, what we want to do is create a grand average, that is a mean across means, so that we get a mean rating of the locomotor skill of baby A and a mean rating of the locomotor skill of baby B for each participant. And then we'll use those mean ratings of baby A's overall locomotor skill, comparing between group 1 and 2, and the mean ratings overall, averaging across fine and gross and play behavior and self behavior. So let me show you how to do that. In the data tab of Jamovi, there's an option to compute a variable, right? So I don't really want to put it there. That was just happened to be the one that I had my cursor in. I'm going to put it over here, right? So I want to create a new computed variable, and I'm going to call this variable baby A grand mean. So that's a average across the averages, or mean of the means. Right? And you can pull down here and choose a number of different mathematical functions. And it's handy, they've got one code in here that is the mean. So if you double click on the mean, it's going to run this mean function on whatever variables you tell it you want to average or create the mean of. So if we scroll down this list a little bit, we want to create an average of all of the baby A's skills. So fine, gross, play, and self. So if we double click the fine motor skills, you see how it ends up in the bracket. So it's going to get a mean of baby A mean fine, and then I'll put a comma so that it knows that I'm going to add another variable to average together. Double click on gross, and then a comma, double click on play and then a comma. We scroll down a little bit, double click on mean self, right? So it's created this little formula here where it's going to get the mean of these 4 variables: fine, gross, play, and self for baby A. So if we click out of there, just press enter, see how it's created a whole set of new numbers in our new baby A grand mean column. Okay, let's create another one for baby B. So I'm going to click in a new column. I want a new computed variable. I'm going to call it baby B grand mean. And then I'm going to choose, pull from the function pull down. I'm going to choose mean again, double click on that. And then I'm going to choose the 4 variables for baby B, double clicking and putting a comma between each one. Double click, comma, double click, comma, and baby B self. All right, so it's created this little formula. It's going to get the mean of these 4 variables. So I can just press enter, and it fills this column with numbers that are averaging across the 4 baby B columns. This one, this one, this one, and this one. All right, so these 2 new grand mean columns are what we're going to use to do our analysis. We're interested in comparing the grand mean averages for baby A between group 1 and group 2, and the grand mean averages for baby B between group 1 and group 2. All right, so let's go back to our analysis view. No, which view do I want? Exploration is what I want. All right, I want to be able to see the data at the same time though. Oh, maybe I don't need to do that. Okay, so we're back to this analysis. If you choose exploration and descriptives, this is what we did in tutorials last time. So I want to get some descriptive statistics and a plot to see what these grand means look like. So I'm going to do the same thing as we did last time. Scroll all the way down to the bottom of these variables, and I'm going to add baby A grand mean and baby B grand mean into the variables box. These are the these new averages that we just created. And then I'm going to say, take the group variable and add that to the split by box, right? So now I have new means that look a little different to the means that we did for individual skills last time for baby A and for baby B. So from these means, it looks like group 2 rated baby A as more competent than group 1 did, and smaller difference, but the other way around for baby B, right? Let's put that on a plot just to see what it looks like. So this, because these are averages, a bar plot probably makes the most sense. And you can see that for baby A, group 2 definitely rated baby A as more competent than group 1 did, which makes sense because group 2 thought that baby A was full term. And for baby B, the difference was much smaller, but it looks like there could be a statistically significant difference between the baby B ratings from group 1 and group 2. So as a general rule, when you're looking at statistical analyses and plots that have standard error bars like this, whether those error bars overlap is a good kind of just a glancing way that you can get some idea of whether the difference between those 2 groups might be statistically significant. If the error bars are really large and they do overlap, then the likelihood is that those differences between the groups won't be significant. If your error bars are relatively small and there's a gap between them, like they don't overlap, then maybe there's statistical difference will come out as significant. All right, so we have some means that we'll use to write up our results. We have some plots that we can include. Now we want to do some inferential statistics. And the question we're really asking is, for baby A, is there a statistically significant difference in the competence ratings from group 1 and group 2? This plot, just eyeballing it, it looks like group 2 rated baby A as more competent than group 1, but we want to know whether the difference is great enough that we could say that that difference, in all likelihood, didn't occur by chance. And then the other way for baby B, we want to do the same thing. Looks like there's a much smaller difference between group 1 and group 2's ratings of baby B. We want to know whether that difference is large enough for us to be confident that it probably didn't occur by chance. So we're going to do 2 independent samples t-tests. It's independent samples because we're comparing different groups of participants. The people that rated baby A in group 1 had a different understanding of what their preterm full-term status was than the group who were in group 2. Different people. So it's independent samples, different groups of people. Okay, so to do t-tests in Jamovi, super easy. We just do, rather than choosing exploration to get descriptives and plots, we choose the next tab over, which is t-tests. And we want to choose an independent samples t-test. And so we're essentially going to do the same thing as we did when we were making a plot. Go down to the bottom and choose these grand means, these averages of averages, and put them in the dependent variables box. And then we want to group by our group variable, group 1 versus group 2. And you can pretty much leave the defaults as they are. We're using a student's t-tests. We have a two-tailed test, that is, we're testing a hypothesis that group 1 and group 2 are not the same, not that group 1 is higher than group 2 or group 2 is higher than group 1. And we can leave all the other boxes unchecked. So if we scroll down the bottom here, you can see that we have the Jamovi has done the two t-tests in succession for us. So it's because baby B ended up being on top, it's done the baby B one first. You can see that the T statistic is 2.29. We have 361 degrees of freedom, and we can see that the p-value here is 0.023. So 0.023 is smaller than 0.05, which means that this test is statistically significant. This baby B difference here that looks like it is quite small, it's actually big enough for us to be confident that it didn't occur by chance. The baby A t-test, the t-value is 8.55, degrees of freedom are 370, and this difference is, the p-value is less than 0.001. So this difference in group 1 and group 2's ratings of baby A is also statistically significant. All right, so that's all the information that you need to write up your results in tutorial today. Find someone at your table who has Jamovi on their computer. See if you can get these results. It's possible that the data you're working with is not the same data as mine. So your numbers might not end up being exactly the same. But don't worry if they're slightly off. It may be that you have a larger sample size than the data that I was working with. Good luck.